So in this video, we're going to look at examples 1 to 4. And I'm going to set it up just a little differently than what the book is doing, okay? Because I want you to have a good knowledge of this, and it's going to make more sense when we go and do this with equations here in a couple days. So I'm going to change this, and I'm going to say that theta equals arc cosine, and actually I want to leave myself more space than that, equals arc cosine of -1/2. Okay, so we learned in the first part of the notes here that their arc sine and arc cosine would be inverses of each other. So what I'm going to do to solve for this is I want to, actually I didn't need the space in there that I was thinking I needed. So I want to find the arc cosine of -1/2, which means I am looking on the graph for this value in one of the coordinates. And we know that cosine is the x value. So I'm looking for that as the x value, and this is going to be my radian measure. So I'm going to go, and remember, I am only allowed to be in quadrants 1 and 2. So I'm restricting it to just quadrant 1 and 2. So in quadrant 1, I'm looking for the x value of +1/2. Sorry, -1/2. And I'm not supposed to be in, I'm looking in quadrant 4, that's why I'm not finding it. There's my -1/2, which means my radian measure that I'm looking for is 2π/3. All right, here it's just giving us, and that's another notation for it. So I'm going to rewrite it as theta equals sine inverse of square root of 3/2. So remember, we only get to work in quadrant 1 and 4 for sine. And I am going to look for where the y value, this time it's a y value, is square root of 3/2. So I'm looking at the y value. Ooh, there's square root of 3/2 right there. And let's just double check. Just look. Is there another square root of 3/2 in those two quadrants? And there isn't a positive one. So it has to be the radian measure of π/3. The next one I am looking for, and I'm going to erase a little bit, is I am looking for the cosine inverse. So theta equals cosine inverse of 2. Well, that would mean I need the x value to be 2. Look at all the x values in that quadrant, or those two quadrants. None of them are 2. Even if I found anything in between, I know I only can between 1 and -1, and we saw that on the graph. So this one doesn't work. We would say that it is outside, it's undefined because it's outside the domain for sine or for cosine. Okay, arc sine. Again, I'm going to erase a bit here. So arc sine is, we're going to say theta equals arc sine of square root of 2/2. So again, I'm looking in quadrants 1 and 4 only. And I'm looking for the y value to be square root of 2/2 because cosine is the y value. So I'm looking here. What do you know? I found it right there, right? And I'm double checking all of them. Nope, that's the only one. So I know theta equals π/4. So again, a little bit different than what we did the other day, because the other day we found all of them. Today we're just finding when it says arc or inverse, we restrict it to 2 quadrants only. Let's go ahead and look at examples 5, 6, and 7 as well. So in example 5, it's saying sine. So theta equals sine inverse of -1. All right, we know sine is valid in quadrants 1 and 4. So I'm looking, and the sine is the y value. So I'm looking for that to be the y value. So 1 and 4, I'm looking for a y value of -1. So I'm looking at all my y values. I went the wrong direction. That was quadrant 1. Here is quadrant 4. So you notice the only y value that has that is 3π/2. Ooh, but I'm not allowed to use that. Remember, we relabeled this as -π/2. So I don't want that one. I want the -π/2 because that's the proper way to write it for in sine or inverse trig. All right, we need arc cotangent. Arc cotangent or arc tangent a little bit different, right? Arc tangent we know is going to be the sine divided by the cosine. Okay, so theta equals arc tangent of 0, which means I am really looking at where the sine over the cosine is 0 over 1, because I can't have a 0 in the denominator, right? So the only way to get that is if my sine value is 0 and my cosine value is 1, which means I'm looking for that point. The only place where that point is, it's not at 2 pi. Remember, that is also labeled 0, so it's got to be theta equals 0. The next one is looking for where tangent inverse is -1. So again, I need the sine divided by the cosine equals tangent inverse of -1. So my sine value would have to be the same as my cosine value, but with opposite signs. So I need these two numbers to be the same. So let's look for coordinates where we have the same number. Okay, so I'm going to go look through all my coordinates. Don't have the same number. Ooh, I've got the same number, but the signs are also the same, because if I put that over the top of each other, I would get +1. So we're almost there. Okay, I keep looking for the values to be the same. Here they are the same, and you'll notice I've got a positive and a negative. So if I had a positive and a negative, I know my answer would be -1. So I'm using this radian measure, but I'm using the negative version of it, the negative coterminal version of it. So this one is actually at -pi/4.